Today we draw the shear force and bending moment diagram of a water reservoir. This is the water reservoir. We consider a 1 meter strip perpendicular to this section. So this is our section, and the water unit weight here given 62.5 pound per feet cube. Distance here given. Here are two support, one is hinge support and other is roller support. So first we draw the stress diagram. Here two types stress acting to the water reservoir, this side, this two side, and this perpendicular, this beam. So here water stress acting to like this, and the bottom stress bottom direction like this, and also this side. So if we draw the stress diagram, it like this. The stress here triangular shape because the stress is maximum here, minimum here, because there is no water, 0, there is maximum height of water 12 feet. So this is stress diagram, this also stress diagram, and here is the distributed load. So the load here, the stress omega h. Omega means unit weight of water 62.5 into the height. H means height of water. So it is 750 pound per feet. So here is 750 pound per feet, 750 pound per feet. Also the distributed load 750 pound per feet, because this throughout this beam all are 12 feet height water. And our hinge support and roller support. So this is reaction. If we denote the point, this is point A, this is point B, this is point C, D, and E, F. So point A, the reaction RA vertical, RA horizontal, because this is hinge support, and here RB, one reaction, this is roller support. Now we can calculate the reaction. So for calculating reaction, we can take the moment in point A. So summation of moment of A equal to 0 clockwise positive. So if we take moment against A, there are first this force. So this force diagram is triangular. So here triangular, we can calculate the stress by area, the force by area. This half into the base, this 12, and the height this 750, and this is this direction. So for this point, this is anti-clockwise. So clockwise positive, anti-clockwise negative. Now for DA section, that means this section, this is the force, distributed force, but this is acting to this direction, bottom direction. So this is also anti-clockwise. So it is minus 750, this distance 8, and this is acting to the middle of this 8 feet. So 8 divided by 2. Now this distributed loss of this section, this is acting clockwise, so this is positive. So force 750 into distributed throughout this length 36 plus 12 48 into this acting that half distance of this 48, middle of the 48, divided by 2. Now this force, which is RB, this is also anti-clockwise, so negative, minus RB into the distance this to this 36 feet. Now this is direction clockwise, this to this clockwise means positive. This is also triangular, so half 750 into this is also acting, this is half into 750 into 12, this is force into acting more for moment. The distance is 1/3 of from this base, 1/3 of 12, this height 1/3, so 1/3 of 12. Sorry, there we should also this triangle force, it also acting 1/3 of 12, so here into 1/3 of 12 equal to 0. So RB, if you calculate this, RB here we given 233.33 pound. Now if we consider the summation of vertical force equal to 0, clockwise positive, we can here the vertical force RAB, this is upward positive, here we take upward positive, the whole distributed load negative, 750 into 8, 36, 44 and 44 and 12, 56 positive plus RB is also vertical equal to 0, but RB equal to, we get here this, so if we place this and RAV get 18666.67 pound. So if we calculate summation of horizontal force equal to 0, clockwise plus B, here horizontal force is this and this and this, so this is this direction, this is this direction, so equal, this is same, so two direction, this cancel. Now R a horizontal equal to 0, so this is 0, this is 18666.67 and this is 233.33 pound. Now we draw the shear force diagram. For SFD there is three part, this part, this part and this part. So first we can calculate this part. This part is, here is 0, so it is like cantilever, so this direction, here is 0 and here is the force is this force, which is this half 12 and 750. So if we calculate this is half into 12 into 750, So force is 4500. So this is 4500. Now this is triangular section, so it should be curved. And for this side also, this is 0 and this is here. So this is the force here, this force acting to this direction, and this force acting to this direction, this force acting to this direction. So here is the, so if we draw the free body diagram to this point and this point, it should be like this. So here 4500, the resultant force acting. Now this is also 4500 to this beam, also this beam 4500, and now force, this is 4500. So this force will be here 4500. Now for this force reduces like this, 4500. This force transit to this point 4500, and this force reduce this to 0. So now this section like this, here is 0, also here is 0, reference line. So this point, this is downward, this is 7, this is negative, minus 7500 into distance is 8. So minus, sorry, so for this section 750 minus 750, because this force is downward, into 8, so 6000. So 6000. This is triangle shaped, inclined shape, because this is distributed load. Now minus 6000 again. Here is this point, there is a vertical force RAB, which is positive upward. So minus plus upward, this is 18666.67. So this is positive 12666.67. So 12666.67. So again distributed force, this point to this point, minus, so minus 750 into the distance is 36, again negative, this is this point 14333.33. so this is straight, inclinedly straight. Now here also another upward force, this RV, so which is positive, plus 23333.33, 9000 here, 9000. Now again here is the distributed load to the 12 feet direction. which is negative minus 750 into 12, 0. This is this point, straight line. This is also straight. So this is the diagram. This is negative, this is positive, this is negative, this is positive. So this point, distance, we can calculate the distance. We can calculate this distance coming from this force. If we divided this force divided by distributed load, then this distance come, and if we divided this force by the distributed force, then we can get this distance. So this distance we have to need for easy moment diagram. 12666.67 divided by distributed load 750, 16.89 feet. And then for this 14333.33 divided by 750, this is 90.11 feet distance. Now we calculate the moment diagram. For moment diagram, this is a parabola shaped. So this we can calculate moment diagram by area method, which is very easy. This is the area of, this is 1/3 of BH. The formula for this area, 1/3 of BH, and this is triangular, this is triangular, this is triangular, this is also, and this is also 1/3 of BH, parabola shaped. So here one thing, here for SFD this force doesn't comply with this, because this is horizontal, but this is vertical. But for moment diagram, here is moment, and this moment coming to this, also from this moment going to this moment, which is transform from one frame to another frame. So for moment diagram, first moment we can calculate this. So the moment will be here, this is, so here is a moment which is, we can calculate positive or negative. If we can draw the free body diagram of this, then the force like this. So the moment here is this direction, and for free body, this frame acting moment opposite direction. So this is, here we can calculate this is negative moment, because it bends, this moment bends this to like this, which is the negative moment, because the here top fiber is in tension, bottom fiber is in compression. This is negative moment. Okay. So this is negative moment, so this is also, so this moment acting through the this direction. So moment, we can calculate moment, which is 1/3 of BH. Here B means this base, which is 12, and H 1/3 of BH, the formula for parabola. So B means base and H means height, which is 4500. 4500 equal to 18,000 moment. which will be also curvilinear parabolic shape. This curve also very sharp from this to this is more sharp. So this 1800 joint start from here 1800 because this moment 1800 000 transit also 18000 to this frame. So here the moment should start from here 1800 which is negative 7 minus 18000. Now for this is also negative, which is we can calculate triangular shape because so half into here base is 8 feet and height is 6000. So here triangular shape, so it is curved shape 42,000. Now this is positive, so triangular shape in positive plus this is also triangle half into here base is 60.89 into height 12666.67. This is positive 64970 64970.03. Now sorry, this is not here, this is here 64970.03. so this is also curve. So now this is also negative minus half into base 19.11 into height 14333.33. This is also negative, so here 71984.94 this point. So curve, it should be like curvical shape of here. Now this force also positive, this section is positive, so plus this is 9000 sorry half into base, here base is 12 feet the height is 9000. So this is negative 17,984.94. This is also curved. Now for this section, this moment transform to this 17,984.94. So why this is not here, this is here? Because for figure diagram, if we draw the figure diagram of this point here, the negative, this is the negative, so here the moment should be like this for base beam. So in this beam it should be this, so that's why it should be this side, and this is the shear force also this point to this point, so this is opposite to this point, so it should be turned to 0 by this, which is positive plus this. 1/3 of B. B means 12 feet into H means 4500. This is some difference. So because this is because of this fraction and this distance, this fraction. So we take it as 0. So this diagram should like this. If we take this more accurately, not round figure, more digit, then this difference of this difference 15 also minimize. So this is our diagram.